Hello YouTube, RJ. In this part 4 of the Larcset build, we're going to finish this up. This is going to be the last video of this series. And what we're going to do today is we're going to mod this thing. We're going to try to make improvement on it. Now I've got a couple issues with this thing. One is the tuning is extremely difficult. It is so fast that you can breathe on it and change. In fact, the band's dead today, so it's middle of the day. 40 meters is shut down at the moment. I'm gonna pop up a clip from a previous video on this and let you see me trying to tune it. Got something, right? SSD. Very touchy. Tuning, too touchy. I mean, you breathe on it.
Oh, there you go, right there.
Okay, as you can see, you just can't tune in things well. So that's number one. That's the first thing I want to mod. I want to take care of that, and you can see why. So we're gonna make a change on the radio. I've got a 10-turn 10K pot that I'm going to replace the pot on this with. That's going to give me about 10 times as fine a tuning. That's going to help a lot. Now that'll bring up another issue, and that is it's slower on the low frequency and higher on the higher frequency. So it gets insane at the top end. So we'd like to have more linear tuning where like the middle, with a 10-turn pot, 5 turns should give me about middle of the frequency, and each side should have about the same amount of band coverage. So we're gonna tweak that, mod that, and try to make that happen. And you'll see what we're gonna do there. And the third big issue that I have is I have a FM radio station about a mile from me, and it's not been a big issue for most of my home-built radios, but this little radio appears to be loose enough to bleed in that. Across the whole 40-meter band listening, you're hearing FM in the background. So I need to do something about that. I think we're going to build a low-pass filter to try to knock that out. And so that'll be the third thing we're going to do. So that's what we're doing in this video. Right now, I'm going to jump on getting this new pot put in. And then a little bit later, I'll come back when the bands come open and we'll see how that does. And then we'll move on to trying to make it linear. And then we'll move on to creating a filter. So I'll see you in a minute. Okay, well, I've got the new pot on, 10 turns. I can't really demo tuning at the moment because the 40-meter band is absolutely shut down. It's midday and there's nothing. So we're going to move on and go ahead and do the next step, and then we'll test it all out when evening comes and sun starts to go down and the band comes live. So the 10-turn pot's in, and what I've done is I went ahead and put the dummy load up here. I've wrapped my cable around the antenna jack and into my spectrum analyzer. And what I want to do now is I'm going to check. As you can see, we've got a spike at 704.166. That's with this turned all the way down. I'm going to document 0 turns, 1 turn, 2 turn, all the way through. Every turn, I'm going to document the frequency, put it in a spreadsheet, come back, and I'll show you how unlinear this tuning is. And then we'll have a baseline to work from, see how well we're doing. Okay, so what I've done is I've punched in the turns and the frequency we saw from the spectrum analyzer. This is stock. I'm going to do the same thing when we get the resistor on and start tweaking. You'll see in a minute what we're up to here. But then I've graphed it out. Here's the tuning for each turn. So for each turn, we get more and more steeper. And really, you get past halfway, about 3/4. Just before 3/4, it really takes off and starts tuning really fast up at this higher end. So we're going to try to get this as flat as we can. That's the goal here. So I'm going to go back over the bench now, and we're going to play around and see if we can't do this. But let me tell you a few things I've done. I've taken this and figured out what the span from here to here is, figured up half that, and came up with what should be our, put here, midpoint. I calculate the midpoint should be 7.173333. Okay, so This should be our midpoint of the tuning. So 0.5, we should try to get 0.5 to 7.1733333. We're currently 7.088333. So we're going to shoot for moving this up, flattening this line. So let's get over the bench. I'm going to show you how I'm going to try to do that. Okay, so let me tell you what I've done. I've come back over to the bench. I've got a 5K potentiometer, linear potentiometer here. I've soldered on across two of the legs so that I can vary the resistance. And I have tapped onto my 5-turn pot from the wiper to the high side. And so what that's going to let me do is I've put this to the halfway point, 5 turns. Okay. And if you look on the scope, I'm putting out 7.13166. And my center point that we want to be at this point is 7.173333. Now we're getting a lot of 666s, 333. It's because of the settings of the spectrum analyzer, so it scans pretty quick. It's only certain spots it can hit. So, but we're down in a point. It's so fine. It's not, doesn't matter. I could slow it down, take a lot longer time to have to wait between each one and get finer numbers, but we don't need that. We'll be good enough, trust me. So here's what we're doing. I'm going to take this pot now. It's all the way turned down. I'm going to start turning it up, and we should see the frequency start changing, and it is. And I'm going to try to get this thing to 1.17333. Right there. Okay, so I'm at the middle of my tuning as far as the pot's concerned, and I'm at the middle frequency. So now what that means is I've put more frequency at the bottom end and less at the top. So we should be a lot more linear at this point. So now what I'm going to do is I'm going to go back to 0, all the way turned down. I'm going to chart the new frequencies out. We're going to put it on a spreadsheet and see how that comes out. See if we're happy with it. If we are, I'll desolder this add-on pot, measure it, and put resistance or fixed resistors across there to get exactly that value on there. And that should give me a nice linear response on my tuning. So give me a minute to get all that done. Okay, I went ahead and collected that data, punched it in. Now we have it here. And this is the chart for this set. I put some linear lines to show you exactly what linear would be. And we can look at the two and compare them. A couple numbers to notice. The smallest step on the stock setup was 0.01 step. The largest step of that group was 0.09. The smallest step of the new one with the resistor is 0.015. The largest is 0.055. Now, why do I care about that? Because the smaller I can make the difference between these two, it doesn't matter what these are, the smaller I can make these, the more linear I'll be. And you can see here that the spread on this changes. In other words, the smallest or largest step changes by 0.08, 80 kilohertz, right? Yeah, 80 kilohertz. The smallest on this, the difference on this one is only 0.04, so half. So we've cut the unlinearities, if you will, of the tuning in half. And this line kind of shows you can see how much we deviate from where we want to be. And you can see that at the midpoint here, we're not anywhere near our center frequency. Down here, it S-turns, which is what I expected to see. That's what happens when you do what I'm doing with the resistor across there. It S-turns a little, but by doing so, it never gets far from the optimum frequency it should be on. And when you get to the midpoint, you can see instead of being way off, we're dead on because we tuned it to be that way. So our midpoint of tuning, our 5th turn, is going to be right where it should be, halfway through our turning range. And none of the steps are very far away. Your worst point will be 1/4 and 3/4 will be the worst, but nowhere as bad as how far you get off with this one. You have a serious speeding up, speeding up, speeding up, speeding up. So this should work very, very well. Our next step now is I'm going to jump over the bench, pull that secondary pot off and measure it without moving it and see how much resistance it takes to get this. Okay, so I pulled that pot loose. I've got it on the Keithley here, and I'm reading 1.603K, so 1,603 ohms. So 1.6K would be great. So what I did is I went ahead and pulled out a 1. I don't have any 1.6K resistors, obviously, but I've got a 1.5K and 100 ohm that'll get me to 1.6. So I'm going to go ahead and series two of these together, one each of these together, and put it across there, and we should be in business at that point. So okay, so I went ahead and made up my little composite resistor with two resistors in series, and it came out to 1.605 within 2 ohms of what the pot was. So I think we're good there. I tuned to the middle position, and we were right where we wanted to be. I went ahead and started at the very beginning, looking at the spectrum analyzer, and turned nice smooth speed continuously through the whole range, and it looked very even moving across the spectrum analyzer. Before, you could literally see it speeding up as you went farther and farther. You can't detect that now. I think we've got it working well. The big trick's going to be waiting till we can, I'll go ahead and hook the antenna up, waiting till we get the band open a little bit in a few hours. We'll be able to tune across the band and try to tune in some stations and see how good our new tuning system works. And if that works great, those 2 problems will be off the list and we can move on. So see you in a few hours. All right, we're back. It's about 4:30 in the afternoon. Seems like there's some stuff on the band, not a lot, but some. So let's go ahead and see how our tuning works. So I'm going to turn this up.
It's pretty quiet. And the only thing is,
Wow, what a difference.
Here and there. So they're mostly omnidirectional, though.
Oh, so much nicer.
Yeah, he was like, oh, you got a link in the back of your house. And then when he Googled my house, and he looks at the link.
Like I said, not a lot of stuff on, but at least I found a couple of things. So much nicer.
I only use it during the winter months anyway, so yeah, I think I'm gonna take that antenna down. The problem is with me is my tower.
The tuning is fabulous compared to before. I'm actually moving the knob to make changes instead of breathing on it. So much more forgiving. I'm going to say that's a big success. Hey, I think we hit a home run on that setup. Now we've got to move on to the next one. So, okay, here we are in ELSIE, ELSIE. I've covered this software before. Great software for designing filters. Here's what I've come up with. This is a 5th order low pass. I designed it to kind of kick in around, I think I went for like 50 megahertz. Figuring 50 megahertz to 100, the radio station is 107.5. So into the FM band is quite a spread. I should be able to get pretty high rejection, I should say. So this is what we've got. Of course, 50 ohm in, 50 ohm out, a 47 puff on both ends, and a 200 puff in the middle with 2 270 nanohenry inductors. These are small enough, and I need a pretty good Q to make this a good filter. So I'm going to be air wounding these, like on a drill bit. I'll have to figure out what size drill bit I need, what size I'm going to use to get close to this. We just need to be pretty darn close to this due to me having such a spread between where we start rejecting. Should be pretty easy to make. So let's look at the plot. Get on the plot. You can see up here at the lower frequencies, my losses are negligible. Let's get her to 7 megahertz here. 7 megahertz to the middle, about 7.1. Yeah, that's about the middle of the 40 meter band. Well, let's go to the top of the 40 meter band so we see the worst losses we're going to see. That's about the closest I can get, is right about there. And it's claiming 0.036 dB, so negligible. I mean, not worth being concerned about whatsoever. When we get up here, the 3 dB point is going to be, because right there's 3 dB and I'm 38 megahertz. So I must have been targeting a 40 megahertz as my 3 dB point. So anyway, you see we drop off quite dramatically over this large band. It's not really that dramatic because we're covering a lot of frequency here, a long ways to go down. But We get down, it's looking like at 107.5, as close as I can get to that, where the radio station I'm having problems with is about a 41 dB reduction. That's pretty good. I'd like to see it around 50, but that'll get it done. I'm quite sure that'll be enough to block it. All right, I got the filter built for us. It was pretty straightforward. 47 puff on each end and 200 puff in the middle. And these inductors are just 3/16 drill bit 10 wraps of 22 gauge enamel coated wires. Not hard to make. Took me a minute to make the two of them. Working very, very well. I've got it hooked up to the spectrum analyzer and it's outperforming what the plot does. Probably because the Q of the inductors are probably better than what I had set for, what to estimate. Looks really, really good. Let me pop up screenshots here. I've got one where I've got the marker at 7 megahertz to see how much loss in the 40 meter band we have. And then I've got the second one I'm bringing up. This one's showing you down at 107.49, basically 107.5 megahertz, where the FM station I'm having problems with is. Got to admit, looks really, really good. Get this put on with the Larcset, put it in a little box or whatever. I should be good. I should knock it right out. We'll give it a test here in a little bit. Okay, so after thinking a little about how I was going to create this tuner setup, I come up with this, basically just borrowing, I looked at a couple of options. One was I was going to 3D print a couple gears, but the gears solution came into a couple problems. One is whenever you put gears together, you always have backlash. So you can never get your tuning right. One way may show correct, but going the other way doesn't. And the gears will wear and get your calibration out. So that's useless. The other thing is it reverts the direction you have to turn the knob for the readout, which, there's some things I could do around that, but I didn't like the idea. I thought there was too many problems with it. So I borrowed a page out of the standard receiver handbook and decided what I would do is 3D print me a pulley and laser cut a couple pieces of 1/8 inch ply. Well, it's 5 millimeter ply for a front and a back plate. Okay, with matching holes here. And then my idea is simply on this side, this is just the pot for the volume. Okay, it just sticks through the front plate. And a shaft runs through both plates. And then I'm going to cut a little groove in the, this is going to be a 1/4 inch hardwood oak dowel. And I'm going to just cut a little groove and put an E-clip here and an E-clip here to lock this shaft in place. And then this is also going to be a piece of wooden dowel. I'm going to make a couple of screw to bite into the potentiometer back here. And so the tuning potentiometer will be in the back. It'll couple to a piece of dowel. I'm going to turn this dowel down a little bit to get the diameter I want, and then run dowel string, numerous runs around here, and then a couple runs around my pulley. And I'm going to 3D print this pulley with a little dowel. And let me see if I can get over here where you can see there's a notch. And what's going to happen is I'm going to loop the string down and around and put a small spring here to keep spring tension down on our dowel cord. So it's just basically a simple radio receiver setup. And the dimensions of this area here will be turned down some. And this diameter here will work out to give me the gearing I need to get me with 10 turns on this to get me, from down here to, in this area somewhere, which keeps me out of this area where I want to put the printing for the jacks. Because the board is actually this is going to sit, should have explained this, get it right here where you can see, these are not even. I've got a piece of board that's going to be the base of this, and it's going to go up flush here and be screwed, and then this side will get glued, and this brace will get glued here but screwed the front plate, so I can remove the front plate to work on it if I need to do anything. So that's the idea. And I'll laser cut me a little pointer, and then what I'm going to do is I'm going to make up a piece of paper and put on here and mark and calibrate the frequencies around, take it off, take a picture of it, take it into Paint Shop and create me a nice printed design. And then I'm going to take weatherproof address label, the big address label that I use for things from time to time. And I'm going to just stick it on here to get all my printing and everything real simple. Just cut the holes for the shafts, put it on, stick it on, and then voila, we'll have our faceplate, black text on white. So that's my idea. Let's see how well I can do at turning this into a usable solution. So next you're going to see is, hey, I got all that built, put together, and just got it working. Thought I'd give you a little demo here. Let me turn it around. Got our indicator here showing us the frequency.
Did you really throw for gun? No. Yes. No. So the problem was resolved. Yeah, the problem's resolved. Yeah. So what's the big deal? There's no big deal. You know, you listen in the morning.
Be coming up on FTA. FTA. Ooh, he's powerful. He's banging it in here. And we can go all the way down to 7.025, all the way up to 7.209. Seems to work pretty good. We're done. We've modded everything we can. We got the tuning working fairly linear. You can see it's not perfectly linear. It gets tighter down here and here, but compared to before, it's so much better. Tuning is a breeze, no problem. It transmits. I get about 2.5 watts out of it, pushing 3 sometimes. Not the 5 watts it's supposed to be. The audio is not the greatest in the world. I'll be honest with you. It's definitely not going to be your Yaesu or Icon or Kenwood, but for such a cheap, simple little radio, it's great. Like I said, you saw the issues I had. It was a little more complicated than it should have been to build. But hey, I'm happy with how it turned out. I hope you are, and I hope this gives you a little inspiration to get in there and home build some stuff. Well, I didn't design this one and build the board and everything myself. I did put the kit together and work through the problems, troubleshoot everything, and then design a tuning setup. So thanks for watching. I hope you enjoyed this process of this whole series of getting this Larcset up and working the way I want it. And I appreciate you hanging out with me. I hope you'll give me a like. And most of all, I hope to see you in the next video.